Good evening. A warm good evening to all of you once again. Let's start with our session for today, which is going to be time, speed, and distance. We're going to cover time, speed, and distance today. Let me share with you my slides. Yeah. Okay, let's start. Did you guys solve the questions I had sent last time? Did you guys solve the sheet I had sent last time in my previous average mixture and allegation class? I think someone needs to manage there. Suvika, I think it's you indeed. Your microphone is still on. Please switch it off if you're not planning to use it. And if you're not able to switch it off, let me know. Okay, yeah, you have. Good, excellent. Of course, as everyone here knows, you can switch on your microphones whenever you want. If you want to say something, please feel free to use your microphones. You can obviously also type, should you have the need, but of course, it makes for a more interactive class if you can sort of read aloud or spell your doubts. If you can say your doubts, that is. Okay, so I understand from Vinay and Kamal, you have solved the sheet. Vinay, you had sent in a query. I don't know if you received a reply from someone else. I have seen that query, and I will talk about it at the end of the day today, because I also want to inform all of you about change in timings and sort of an increase in the number of hours per week for you guys. So we'll talk about that at the end of the day, at the end of the session. And yeah, let's start with TSD right now. So what are we going to cover in TSD today? We are obviously going to talk about formulae and talk about units a bit, the conversion of different units in time, speed, distance. We're going to talk about different sort of questions, different type of questions, with special emphasis on two basic type of questions. We are going to talk about average speed, of course, and about relative speed. And average speed in general is not a very exhaustive concept. Relative speed on CAT can be a very exhaustive concept. I am going to introduce the basics of relative speed and cover questions that are relevant for GMAT a bit more. And when I give you the homework, there will be a few more questions that will be more relevant for the people preparing for CAT. So yeah, that's about it. That's what we'll cover today. So let's talk about the basic formula. Of course, the best thing about time, speed, distance is that there's just one formula, which is distance is equal to speed into time. Common units for speed, of course, are meter per second or kilometer per hour. And you can convert from meter per second to kilometer per hour. 1 kilometer per hour is essentially 1,000 meters by, you can obviously, if I'm talking about 1 kilometer per hour, I'm talking about 1,000 meters to be divided by 3,600 seconds. Yeah. So 3,600, of course, because 1 hour is 60 minutes into 60 seconds per minute, which makes this 1,000 by 3,600 very simply 5 by 18 meter per second. It does help. I mean, this is a very simple calculation, but it would help if you remember that 1 kilometer per hour is 5 by 18 meter per second. It's fairly simple. Which brings me directly to these two simple questions. Can you calculate them, please, for me? Please try these out. If the speed is 50 km per hour, what will be the distance covered in 1 minute 12 seconds? And if a car covers A kilometers in B hours, then how much time will it cover 200 meters? Simple questions, please try. Yeah, any answers to the first question, guys? Any answers to the first question? Okay, what about the second question? Nitika, both are fine. Okay, does anyone have any problem in this question? In either of these two questions? Please ignore the file I've sent for the time being. I've sent you a file. You can download it and keep it with you. We won't be using it in the next at least half an hour, I guess. Any problems in either of the two questions? Okay, cool. In question number one, you could simply have converted uh, 1 minute 12 seconds to to an hour. 1 minute 12 seconds is 72 seconds, which is 72 by 3,600 hours. I hope that is clear. Yeah. We don't need this. Now, what I just want to say here very quickly is that 72 seconds is nothing but 72 by 3,600 hours. And yeah, in question number two is a kilometer in B hours. You know immediately that the speed is a kilometers in the hour. So per hour it is a by b, kilometer an hour. If you know the speed and you know the distance in this case was 200 meters, which you can say is 1 by 5, 1/5 of a kilometer. You know the speed, you know the distance, you can calculate time. Okay, I'm assuming no one has a problem in this. Cool. Very simple question. Let's move to the next concept, sort of. Now, what are we looking for when we talk about type of questions? The two main type, other than obviously concept driven, other than the questions that involve concepts of average speed or relative speed or some other concept. In whatever type of question you see or whatever concept it is based on, the most common types are ones in which either distance is constant or ones in which time is constant. And if you can't immediately understand which one is constant, then I would advise you to look for something that is constant, because when either of them becomes constant, uh, your question becomes simpler, easier to solve without a shadow of doubt. Now, let's talk about what happens when distance is constant. Questions based on constant distance are based on manipulation of ratios. And rather than looking at the formula given here, let's look at um, a few examples. Let's say the distance from my home to office, let me just say, is 100 kilometers. Yeah. So I'm ignoring the units, but of course, I'm ignoring the units only because I'm taking simple units. I'm taking sort of units that are not in disagreement with each other, in the sense that, say I'm talking about kilometers here. Let me take the speed in kilometer per hour, and then obviously if my distance, the distance from home to office is 100 kilometers and the speed is 50 kilometers per hour, it will take 2 hours for me to cover the distance. Now, what would have happened had I taken, instead of 50 kilometers per hour, 25 kilometers per hour? say I'm traveling one day from home to office at 50, I'll take 2 hours. If I travel at 25 km per hour, I'll obviously take 4 hours. Finally, because the product for both has to be 100, the distance from home to office. Now, what I want to say here is, since my distance is changing from 50 to 25, it's becoming half. Yeah, the time must to ensure the same distance covered, the time must become twice. That is a kind of relation. Speed, these were the first initial were the sort of first part is the speed, the second is the time. The relation between speed and time is inverse. They're inversely related to each other. If speed becomes half, time will become twice, and that is fairly simple. That is very direct, because say, let me just take very general units. If distance covered were to be s into t, then if my new speed becomes s by 2, to ensure the same distance covered, my time must sort of cancel out this. Let me write s by 2 instead as half s. So my ratio that is being sort of now connected to s in front of s, or the new coefficient of s, has to be cancelled by the new coefficient for t, which therefore has to be 2 by 1. To cancel this out and get again the distance covered to be s into t. That is what will make it constant distance. What do I mean? Therefore, say if my distance covered is s into t and my new speed is 4 by 3s, then my time has to be 3 by 4 of the initial time, inverse of 4 by 3. Yeah, because for the very simple reason, as shared in the slide, if say in instance 1 my speed is s1 and then time is t1, then distance constant is s1 into t1, which is also equal to s2 into t2. The product of speed and time at some other instance 2, then speed of 2 by speed of 1 becomes time of 1 by time of 2. Inverse relation. So if speed 2 is half, then time 2 will be twice what we've just found out. Or if speed 2 is twice, if this relation s2 by s1 were to be 2 by 1, then of course clearly t2 by t1, if you solve this, would become 1 by 2. Inverse relation. I hope this is clear. And I think this question is going to be a simple test of the concept shared. Cool. Why don't you try question 1, guys? Please try question number 1. The person increases his speed by 25%. He reaches office 20 minutes early. What is the usual time taken by the person to reach office? Any answers to this question? Indeed. So, continuing on what we had talked about here, here the assumption is, of course, that the person leaves for office at the same time. Indeed, person leaves the office at the same time every day, and thus just talk about this a little bit again. So say the everyday distance covered by that person from home to office is covered at a certain speed s, taking a certain time t. Now, since the speed has increased by 25%, now what does that mean? We've covered this in ratio and proportions, um, I guess, around 2 weeks ago, the last couple of classes. New speed is nothing but initial speed plus 25% of initial speed. So s plus 25% of s. 25% is, of course, 25 by 100. Or you may directly remember 25% as 1 by 4. S plus s by 4 is my new speed, which is 5s by 4. If my new speed is 5s by 4, clearly, now this is what I wanted to sort of explain. Since speed has become 5 by 4 times, the time will have to become 4 by 5t, where t is, of course, the normal time, and s is, of course, the normal speed, the speed normally traveled at and the time normally taken. And clearly, if speed is increased, the time will decrease from the initial time. Now, the question says that person reaches 20 minutes early, which means that this difference, the difference between the normal time taken and the new time taken, must be 20 minutes. And you can solve this. T minus 4 by 5, t is t by 5. T by 5 is 20, t has to be 100 minutes. Yeah? Is this clear? If anybody had a doubt earlier, I hope this has become clear. The concept is clear. Excellent. Could you just follow what I just shared and attempt question number 2? Could you just try question number 2? In fact, maybe even question number 3. There is a little bit of difference, between the first 2 questions and the third question, but they're based on the same concept. Please also try question 3. Dinesh, check your answer. I don't think it is 20. Please check your answer. Possibly Anubhav. Okay, let's. Uh-huh. Okay, please try third. If you attempted question number 2, please try question number 3, and then we discuss both. Okay, cool. I guess most of you have solved it. Most of you got it right. The answer to question number 2 is indeed 40 kilometers, and of 3 is indeed 20 minutes. Uh, did anyone have a problem in these 2 questions, either of these questions? Any problem in either of these questions, guys? Okay, cool. Um, well, they're based on the same concept, not very different to what we've discussed. So I'll briefly just touch upon these 2 questions. Question number 2 talks about normal speed being 60, speed today being 40. Clearly, speed has become 2/3 of the initial speed, which means time will have to become 3/2 of the initial. Yeah. Directly jumping to question 2. Initial speed was 60. Let's say time taken is t. For the same distance, if speed now is 40, clearly 2/3 of 60, time has to become 3/2 of the initial time, therefore becomes 3/2t. Yeah. Now, if you don't feel comfortable directly, or if you're not able to directly understand what ratio this is, so when I say it's 2/3, if you are not able to calculate why this is 2/3, or don't understand how this is 2/3, you can go back to what we discussed in the slide all the time. That essentially what we're talking about is that since distance is constant, S1 into T1 is equal to S2 into T2. So if in instance 1, speed is 60 and time T1, let me call that time T, yeah, the normal time here, and S2 is 40, then time T2 becomes, this is also one way of calculating. Time T2 becomes, you can calculate 60/40 becomes 3/2t. This is also one way of doing, of solving the questions. Essentially because S1 into T1 and S2 into T2 are the same constant, which is equal to that distance that the person covers. Yeah. And essentially the question here says, since I now take 20 more minutes, the result is that I'm taking 20 more minutes. It essentially means that the difference between the new time and the earlier time, 3/2t minus t, or t/2, this must be 20 minutes. And now you can solve. You have time, which is 40 minutes, which you can convert to hours. 40 minutes becomes 40/60 hours. You have time in hours. You have the speed 60. You can get the distance if you multiply 60 and t. The distance obviously has to be 60t. 60 into 40/60. 60 cancels out, you get 40 kilometers as your answer. And question number 3 was also very similar. And yeah, since you didn't have a problem, I'll jump to the next question. So all I want to say is we will keep talking about manipulation of ratios and using ratios to solve faster. Okay, the other concept, time constant. When time is constant essentially here. And of course, if time is constant, time is distance by speed. If distance is speed into time, time becomes distance by speed. And again, if time is constant, then if say in instance 1, distance covered is d1 at speed s1, then d1 by s1 must be d2 by s2, which is distance covered in instance 2 upon speed of covered in instance 2. d1 by s1 equal to d2 by s2 can be rearranged to say d2 by d1 is equal to s2 by s1, which essentially means that distance is directly proportional to speed. Very, very direct, very, very simple. d2 by d1 is s2 by s1. The ratios of speed will be reflected in the ratios of distances. So what does that mean? Let me say give you an example. Let me share a question. Say you have a 100-meter race. Now this 100-meter race is being there are two competitors for these 100-meter race. This 100-meter race, A and B. Yeah. If the question doesn't say anything else, you will assume that A and B start at the same time. So there's the same starting point. A and B are starting at the same time. If the question now says that A beats B by 20 meters, let's say the question says this. Now, what this essentially means is that by the time A has reached the finish line, the 100-meter line, B would have only reached the 80-meter line. Yeah. Now, can I assume that can I infer that since A and B started from the same point at the same time, by the time A has covered 100 meters, B has only covered 80 meters, which means time is constant for both, time is same for both, and thus distance covered by A upon distance covered by B will directly give me the ratio of speeds. It will be speed of A upon speed of B. Since distance covered by A is 100 meters, and at the same time distance covered by B is 80, the ratio of speed of A and B becomes 100 by 80, which is 5 by 4. 100 is 20 into 5, 80 is 20 into 4, and thus this allows me a quick comparison, a quick understanding of their speeds. SA by SB becomes 5 by 4. It's very simple. Yeah. Now this is a question on race or races, and it's a common question for sort of questions, common question type or common question structure for the question type in which time is constant. And I just want to quickly talk a bit about what head start means. We've seen what beats by means in the previous question as an example. I do want to talk about both of them a bit. So let's just talk about first beat by or beats by. One person beats the other by. Now, if A is beating B by meters, by some meters. So let's just fix the structure of the question. Let's assume we're talking about a 100-meter race. If in a 100-meter race, A beats B by say 20 meters. Yeah. Then clearly, as we discussed, we got speed of A by speed of B equal to 5 by 4. What would have happened, or what could we have inferred had the question said A beats B by 5 seconds as a separate piece of information? Could we have also then inferred something about their speeds? Could we have got some relation between their speeds? Now, first of all, what does this mean? What does A beating B by 5 seconds means? It means that by the time A has reached the finish line, let's say this is the finish line, then B still has to, it is B that has to run for 5 more seconds to reach the finish line. Just as in the previous case, by the time A had reached the finish line, B still had 20 meters to run. They're very similar. But in case number 2, the information doesn't allow for any direct comparison between speeds. It only says that if A takes P seconds to cover 100 meters, B will take T plus 5. That is the only kind of relation we get and nothing else. Yeah, we don't get direct values here. Is this clear? Is this clear, guys?
So just one thing here.
Yeah. Go ahead.
At this second information, we won't be able to solve this problem, right?
We won't be able to solve this problem. No. Okay, let me show you what we know from this. Say the distance, in fact, not say, we have assumed 100 meter race, then clearly distance covered by A, by the time A and B have started together, from, let's say this is the starting point, A clearly has covered 100 meters, excellent. B hasn't. Now what this beating by 5 seconds tells us is, say the time taken by A, if the time taken by A to cover 100 meters is T, the time taken by B to cover 100 meters will be T plus 5. So by the time B covers 100 meters, TB, the time taken by B will be T plus 5, excellent. Which means that 100 distance is speed into time, speed of A into time T, 100 is also speed of B into time T plus 5. Since both are 100, you can equate the two. And what do you get here? You get SA by SB, just divide. You'll get SA by SB is T plus 5 by T. And thus we don't have any numerical piece of information. Umesh, isn't distance same in type 2? Yes, it is same. I have taken it to be 100 in both cases. But that only allows us the comparison marked here. Nothing more than that. Yeah. Okay. We could have simplified this and talked about this a bit more, but it will not give us values. That's the point. This piece of information will not give us values. Okay, cool. What is head start? Now, head start is a bit different. And say if you've been told that A gives B a head start of 20 meters. So A is giving, or A gives B HSA head start of 20 meters in a 100-meter race or in any other race of some other length. What is happening is A is waiting at the starting point till B starts running and covers 20 meters. So A will not, for A, the race will not start till B is at the 20-meter mark. That is what head start means. Now this could also have been 20 meters, or say again, let me say take the same value, 5 seconds. It essentially means the same. That either in case 1 till B covers 20 meters, or in case 2 till B runs for 5 seconds. A will not move, and thereafter, once B has covered either these two milestones, or either 20 meters or 5 seconds, then A will start to run. And then they are both running in the same direction, trying to finish the race. Yeah. Now, if you had been given any other piece of information, then you may have been able to infer something. But that is as a concept. I mean, head start doesn't allow you anything more. You can't now decipher or you can't infer anything about speeds of A and B like we had done in the previous concept. You cannot find anything, it remains a question mark. However, we'll see how questions use the concept of head start and ask you to calculate a lot of other things. Yeah? Okay, cool. I think uh, maybe these 2 or 3 questions may help you sort of check if you've understood the concept. Let's quickly solve one first. Let's talk about 2 and 3 later. Please just solve one. Please solve one and tell me what the answer is. In a race of 100 meters, A beats B by 10 meters. What is the race? Yeah, it's 10:9. By the time A covers 100 meters, B covers 90. Yes. So it is very direct. And as simple as this looks, all the other questions that we are going to do are going to be similar. We understand the distance covered by A is 100 meters, and the same time here is constant. At the same time, distance covered by B is 90 meters. And of course, you assume time is constant because if you're talking about a race and the question doesn't say otherwise, we assume that they both started at the same time from the same point. And thus A by dB or 100 by 90 will be equal to will be equal to speed of A upon speed of B, which of course comes out to be 10 by 9. Okay, cool. This is a simple question. Let's try questions that are slightly more complex. Question number 2 is a data sufficiency question. Question 2 is data sufficiency. And in question 2, when the question says lead and head start are absolutely the same. There's no difference between lead and head start. Please try both. So anyone here who's not phased or doesn't understand the concept of data sufficiency? I think there are a few students today who are attending an online session for the first time. Anyone here who doesn't understand what data sufficiency is? Okay. Okay, good. Then please do give me the answer to question 2 in the same. I can explain, of course. I will explain that at the end. So, I generally ask students to read through data sufficiency. If you don't know about data sufficiency, you can ignore question number 2 for the time being and solve 3. And when I discuss the solution or the process to solve question 2, I'll probably talk about data sufficiency a bit. But in detail, I'll only talk about it at the end. Yeah. $20 Krishna is okay. we've already got two different answers to question 2. Let's see. Please try question number 3 as well. If you're making quadratic equations in question 3, then you're probably not solving it the right way. There are many ways you can solve 3. If you're making quadratic equation, then maybe you should relook at the question. Let's start discussing in 1 more minute, guys. Okay, let's discuss. Krishna, well done. 48 is indeed the right answer. Any problem with question 2, guys? Any problems with question 2? Oh, yeah, of course. 2 is indeed D. The answer to 2 is D. Both are possible. Both you can answer the question using either statement alone. So for anyone who had a problem or who's new to data sufficiency, just briefly talk about data sufficiency. What data sufficiency questions require you to do is not to calculate the answer. You don't need to calculate what the exact answer is. You only need to check in the two statements given, statement 1 and statement 2. If you can solve using these statements, you can solve the question using these statements. So the typical format of a data sufficiency question is you'll be given an initial statement, the one that I've marked, that are the one I've highlighted. You'll be given an initial statement which may have some piece of information or some fact. Like in question 2, the fact is that the race is 100 meters. Yeah. And of course, it seems that there are two competitors, A and B. There may be more, but yeah, we need to focus on A and B only. And the question is how much lead or head start can A allow B to ensure that both finish at the same time? So it is A allowing B the head start, which means A definitely has to cover 100 meters. Yeah. If both have to finish at the same time, then A must cover 100 meters and B will surely cover less than 100 meters. But how much is what we have to calculate given statement 1 and 2. And now what data sufficiency uh, asks you to do is, it will give you 5 options. And the 5 options represent the different ways in which you can check if the data given is sufficient. Option A is that statement 1 alone is sufficient. So A would be the right answer to any of the data sufficiency question if statement 1 alone is enough to solve the question, and this implies that statement 2 alone is not. Yeah, that is the only time A is the correct answer. And if statement 2 alone is sufficient, but statement 1 alone is not sufficient, then option B is the correct choice. If statement 1 alone is sufficient, while statement 2 alone is also individually sufficient, so either of the statements alone is sufficient, then D is the right answer. But if you need to combine them, if you need to combine the information given in 1 and 2, so if it's statement 1 plus statement 2, if the information is combined, and then you are able to solve the question, then of course the right answer is option C. And E is, whatever you do, you won't be able to solve the question, which means even after combining, if you're not able to solve the question, then E is the right answer. And of course, option E also means that statement 1 alone is not sufficient and statement 2 alone is not sufficient, neither combined sufficient. Yeah. In our question 2, statement 1 is that the speed of A is 12.5 meter per second, while the speed of B is 10 meter per second. Yeah. Can you find? Can you check and find out if this piece of information is enough to tell you how much head start should A allow B? So yeah, just to diagrammatically represent what we know that A starts from the starting point, while B gets a head start, a certain lead, which is what we have to calculate. Let's say this is the head start. But finally, both have to reach the 100-meter line. Omega 3 is not 32, I'm afraid. 3 is 48. We'll discuss this. We'll discuss 3 is a good question. We'll discuss question 3. So, yeah, in this question, statement 1 is telling you that speed of A is 12.5, B is 10 meters. It is absolutely clear the distance covered by A has to be 100 meters. Yeah. And now this is the kind of question in which T is constant. Time is constant. So after B has been allowed that head start, both B and A run for the same time and must reach the 100-meter line at the same point. Which means that since time is constant, speed of A by speed of B, which is 12.5 by 10. If you simplify this is also 5 by 4. This has to be equal to distance covered by A upon distance covered by B, has to be 100 by distance covered by B. The distance covered by B is the remaining distance. Let me say this is the distance covered by B. This also happens to be 100 minus the head start. So if you use this, if you solve this, you will get distance covered by B is equal to 80 meters. Which means the head start must be 100 minus 80, 20 meters. Yeah. Now, I've solved it here, but the point where you could have stopped here. Once you realize that enough information is given, once you realize that you will be in a position to solve for dB, for the distance that B needs to cover, you should stop. Because 20-meter is not something the question is asking. You don't need to find the answer. You only need to find if statement 1 alone is sufficient, and it clearly is sufficient. You are in a position to solve. What about statement 2? Statement 2 also gives you the same. Speed of A upon speed of B is 5 by 4. And since you know the distance covered by A, this is also equal to distance covered by A upon B. Since you know A is 100 meters, you can calculate dB. Stop here. You know that you can solve for dB now using this relation, using these two equations, these two ratios rather. You can stop and say, yes, indeed, statement 2 alone is also sufficient. And thus, since 1 alone is sufficient and 2 alone is sufficient, the right answer has to be option B. So hopefully, anyone who has not solved data science equation before, this may help a bit. I hope this is clear. Okay, cool. What about question number 3? What about question number 3? A beats B by 12 meters and C by 18 meters, whereas B finally beats C by 8 meters. What is the length of the race? So let me quickly talk about the two approaches to this question, the lengthy one and the short one. Oops, sorry. So the length of the race is not given. Let's say it's L. L is what we need to calculate. What we do know is that the question mentions 3 competitors, A, B, and C. And by the time A has reached the finish line, B is 12 meters away from the finish line. A beats B by 12 meters is what the question says. And C by 18 meters, which means B and C are a further 6 meters apart, which is how A will beat C by 18 meters. Yeah. Now, it is important to note that B hasn't reached the finish line yet, but when B does reach the finish line, the question says that B beats C by 8 meters. Yeah. So now, what is the difference between these two situations? From difference between situation 1 and situation 2. Let's say this is situation number 1, and this is 2. In 1, B is yet to reach the finish line. In 2, it has reached. In 1, B and C are 6 meters apart, while in situation 2, B and C are 8 meters apart. Now, since in time, speed, distance, we assume that all objects are traveling at the same constant speed, it can be inferred, it can be concluded that by the time B covers 12 meters, so this is the intuitive approach. I'll talk about the quadratic equation approach as well. The intuitive approach is by the time B is covering 12 meters, or for every 12 meters that B covers, the distance between C and B increases by 2 meters. Yeah. For every 12 meters covered by B, the difference between B and C increases by 2 meters, or it becomes 2 meters. Is this clear? So what would that mean? That would mean that if the final distance between B and C is 8 meters, now this is simple ratio proportion, unitary method. For every 12 meters, the distance is increasing by 2 meters. For the distance between these two to be 8 meters, for them to be 8 meters apart, the distance covered by B must have been 4 times. This is 2 into 4, 8 meters. Distance covered by B must be 4 times, 12 into 4, 48 meters. So by the time B covers 48 meters, they will be 8 meters apart, and thus the length of the race must be 48 meters. Is this clear? Before I go to the equation approach, let me know if this is clear, guys. Okay, doubts anyone? Does anyone else have any doubts? Okay, cool. What is the lengthy equation approach? It's the same. It's considering time as constant. Okay, Lakshya, I can explain this again. Just focus on the difference between the two diagrams, 1 and 2. In the first diagram, B and C are 6 meters apart. In the second, B and C are 8 meters apart. Yeah. So the distance between B and C has sort of increased by, let's not say equal, let's say it has increased by 2 meters. It has increased by 2 meters in the same time as B has covered 12 meters. So if B runs an extra 12 meters, or by the time B runs an extra 12 kilometers, the distance between B and C increases by 2 meters. Now, for the final distance between B and C to be 8 meters, yeah, which means 4 times this 2 meters. For the final distance between B and C to be 8 meters, 4 times the 2 meters, the distance covered by B also has to be 4 times the distance given here. So 12 meters into 4. By the time B covers the length of the race, or 48 meters, B and C will be 8 meters apart, which is what we want. Because, that gives us the length of the race, 48 meters. I hope this is clear. I don't know if there's any other way of explaining this. The only other way I could have explained this is, again, going back to the basics. Say, I'm starting with the answer now. B and C start at the same time. Yeah. B runs a certain length and C runs a certain length, and the distance between them becomes 2 meters, let's say. In fact, let's say B is running 12 meters and C is running 10 meters. So for every 12 meters run by B, C will run 10 meters. So when it covers another 12 meters, means it will be on the 24-meter line. C will be on the 20-meter line. Then 12 more meters, 36-meter line. Then C in the same time will cover 10 more, will be at the 30-meter line. 12 more meters, 48-meter line. C will be at the 40-meter line. Clearly, the distance between them is now 8 meters. Now, this 8 has come up only because of this ratio. That by the time B is covering 12, the distance between them is coming out to be 2 meters. Which, of course, if I multiply by 4, I would have got 40 or 48. And the difference between them would have also been multiplied by 4 and come out to be 8 meters. So this approach could have given me the length of the race. I hope this is clear. Okay, the only other way, Lakshya, is this clear? Okay. The only other way, as I said, the equation approach, which is if you focus on diagram 1, and if you consider the length of the race to be L, and focus on B and C only. If you focus only on B and C, what can you say? Can you say by the time B covers L minus 12, so distance covered by B is L minus 12, in the same time the distance covered by C will be L minus 18. Let's have this. One second. Yeah. Yeah, in the same time, distance covered by c will be L minus 18, which tells me that since time is constant, the time for instance 1 is constant, L minus 12 by L minus 18, the distance covered by B upon distance covered by C, has to be speed of B by speed of C. And from the second picture, I get that by the time B covers L meters, C will cover L minus 8 meters, which again tells me that the speed of B by speed of C has to be distance covered by B, L by distance covered by C, L minus 8. If you equate these two, you'll get your answer. L minus 12 by L minus 18 is equal to L by L minus 8. So you would definitely not, I would not recommend using solving or making a quadratic equation. I would here probably have recommended using options. You could have used options had you been given those options, or use the first method, which is more intuitive and wouldn't really need you to make any equation or solve. If you understood it, it would have been faster. Yeah. Shall we move on to the next question? Let's move to the next question. In a minute. Yeah, let's. So the next question concept is average speed. And average speed is not the arithmetic means of speed. It is not simply say you're so you can have a look at the question below. If I travel from point X to point Y at 60 km per hour and come back at 40 km per hour, then what is my what is my average speed for the journey? The answer, let me sort of spare the suspense, will not be 50. The answer will not be 60 plus 40 by 2, clearly. The answer will be this. Average speed is total distance by total time. It is not simply arithmetic mean of speeds. And maybe you can try, or you can try out this question using the formula. Please just quickly try this question before we move to the next concept. '48, indeed. This in the history of time speed distance is the सबसे घिसा हुआ question, what we call घिसा हुआ. This has been used so many times over and over again, the same values 40 and 60. And yet I often hear in class the answer 50. It's not 50, it's 48. And most of you have got it right. And for those who are wondering how, let me just briefly talk about how this is 48 and not 60, and also talk a bit about average speed. Now, the thing about average speed is, the best thing is that you can, in most questions, pick numbers. You can assume values for distances. So in this question, you've been given a point X and a point Y, and the person or the object in question is covering distance X, Y or x to y at 60 km per hour and coming back at 40 km per hour. Yeah. Now, whenever the question doesn't give you any distance, you can assume distance. There's nothing wrong with it. I could have taken a distance to be d, or taken the distance to be an LCM of 60 and 40, and obviously got the same answer. Let me show you. Let me take distance to be d and show you why I'm saying this. Average speed is of course going to be total distance. So if this distance is d, then from x to y I've covered distance d, and from y to x again back d. So the total distance covered in the to and fro journey is 2d, and the total time is going to be the time taken from x to y. Time is distance d by speed 60, and from y to x distance d by speed 40. Clearly d is going to cancel out. You have 2d upon d by 60 plus d by 40. D is going to cancel out. You'll be left with d into 2 in the numerator and d into 1 by 60 plus 1 by 40 in the denominator. And this d cancels out. Since these cancel out, it makes sense to take d as something that will help you, solve your question faster. And that would, of course, have meant not using these fractions. Taking some suitable value that would have helped you avoid the fraction, which would have been the LCM of 60 and 40. You could have taken distance to be LCM of 60 and 40, which of course is 120. Or you could have taken any multiple of 120. Yeah. So the average speed from here is you'll get, if you solve this, you'll get 48. This will be 2 by 122 plus 3. Yeah. And 120 goes to the numerator. Your answer would have been 240 by 5, 48. Had you taken 120 kilometers as the distance, it would have been the same, because then the total distance would have been 120 into 2, 240, upon, if you're covering 120 at 60 km per hour, 2 hours. If you're going back and covering 120 at 40 km per hour, you take 3 hours. The total distance covered is 240. Total time taken in the to and fro journey is 5 hours. 240 by 5 obviously gives you the same answer, 48 km per hour. Yeah. So there really isn't that much when it comes to the concept of average speed. But of course, you may have some different type of questions, and why don't I try these two questions? Please go ahead and try these two questions. You can give me the answer to question number 1. You can give me an approximate answer. There is no problem. 1 need not be the exact answer. I would, of course, be happy if you avoid the use of calculators. 46 or approximately 46 is correct. Good. What about question number 2? So Vicar, please check your answer again. I'm afraid 48 can't be the answer to question number 2. Okay, let's discuss, guys. In question number 1, I just shared that you can assume distances if distances aren't given at all. Now, what will I assume the distance is as here? You've been given half the distance at 40 km per hour, half the remaining at 60 km per hour, and the remaining at 50 km per hour, which essentially looks something like this. So this is the total distance. The first half will be covered. I think what was the speed? It was at 40 km per hour. Half of the remaining, which means 1/4, at 60 km per hour, and the final, this is d by 4, half of and the remaining, sorry, which is again d by 4 at 50 km per hour. You can use d or assume d is equal to some multiple of 40, 60, and 50. Since you are talking about d by 4 here, uh, you know, I think it makes sense to take 1200 meters. Just take 1200 kilometers rather, not meters. I'm taking d to be a multiple of 240 because this is d by 4 by 60 and d by 4 by 50. So LCM of 240 and 200. And I've taken d to be 1200 because this helped me simplify the question and change these values to half the distance, which means 600 kilometers at 40 km per hour, which means time taken here is 15 hours. 600 by 40 is 15 hours. Then 1/4 of the distance, which means 300 kilometers at 60 km per hour, which means 5 hours. And again, 1/4 the distance, which means the remaining 300 at 50 km per hour, which means 6 hours. So my total distance to calculate the average speed, total distance is of course 1200 kilometers. Total time is 15 plus 5 plus 6, 26 hours. So that gives me my average speed. This is 600 by 30. This is more than 46 and less than 47. This is 40. Sorry. This is 46 point something. As I said, approximate answer is good. Vinay, is that the answer to question number 2? Is that your answer to question 2? Okay, let's see. I think it is correct. I don't know if it was 20 by 3 or it was something. I don't remember the exact answer, and I've not written it down. And I haven't heard from anyone. I haven't seen any other answer. Okay, if everyone says it's 6.66, it must be excellent. Cool. Yeah. So now X covers a distance of 60 kilometers in 4 hours, traveling partly at 16 km per hour and then covering the remaining at 10 km per hour. this may look like a average speed question, and you could use average speed, but the simplest way of calculating this is that you are traveling at 10 km per hour, say for time t, and then at 16 km per hour for time 4 minus t. Since the total time traveled is 4 hours, if you take t hours at the rate 10 km per hour, then you must take 4 minus t hours for 16 kilometers. This combined distance has to be 60 kilometers. Yeah. So just solve this. This is really quick. 10t plus 16 times 4 minus t is 60. And what you need to calculate is 10t. You can solve this. This will come out to be, I guess, t will come out to be 16, 4 by 6, 2 by 3 hours. And of course, then the distance covered at 10 km per hour is 10t. So 10 into 2 by 3 comes out to be 20 by 3 kilometers. Yeah. Any problem, guys? No. Okay. Then that gets me to the concept relative speed. Now, let me not talk about relative speed through the slide. Let me talk about relative. Let me go back and explain what relative speed is. So, you may have read this in school. If two objects are moving in the same direction, let's say this is A and this is B, then their relative speeds are the difference. And let's say A is traveling faster than B, SA greater than SB. So in this diagram, it would obviously mean that A will sooner or later catch up with B. Yeah. At what relative speed? It will be SA minus SB, since they are both moving in the same direction. However, if the two were approaching each other, they were moving in opposite direction. A is moving here and B is moving here. Then they'll approach each other faster, very fast. And the relative speed at which they'll approach each other is essentially the relative speed at which the distance between them is decreasing. That becomes SA plus SB. Yeah, you've seen this before. Now, what I want you to also remember, understand is that relative speed follows the same formula. There's nothing beyond this formula in time speed distance. Everything is based on this. Distance is always speed into time. And for this concept to be used in relative speed, there's only a sort of slight change. And the change is that relative distance becomes equal to relative speed into time. And relative distance essentially is the distance between two objects. So, if say we're talking about two objects here, A and B, two people, two cars, whatever, then relative distance is the distance between these objects. What is the relative speed? It's simply the speed at which the distance is decreasing. It's always the speed at which the distance is decreasing or increasing. The sort of speed at which distance is increasing or decreasing. So do keep this in mind. Relative speed is relative to the measuring the relative sort of the movement of one relative to the other, which means how much is one moving faster than the other, or by what speed are they approaching each other. In the first one, this would have been by what speed is one faster than the other. In the second, it would have been the speed at which they are approaching each other. And time is the common time. Now, what I mean by common time is you'll get a lot of questions in which one object starts, say, from 12 p.m. and the other object starts from 2 p.m. Yeah, one is starting at 12 noon, the other is starting at 2 in the afternoon. Now, for those 2 hours between 12 and 2, there's nothing relative about their speeds or their distances because the second object is not moving. To use this formula, please make sure that the time you use is the time that is common to both. Both are moving towards or away from each other at the same time. That is when you can use the formula. So, in fact, you must have done this in school. Remember all concepts used in school, no problem. The only thing I want you to remember is T must be common. You can't have a situation in which one is moving and the other is not. So that's what has been summarized in this slide. If traveling in the same direction, the relative speed is always difference of speeds. If the objects are traveling in the opposite direction, relative speed is sum of speeds. Oops. Uh, have a look at this simple question. In fact, okay, yeah, you can try this question. I'll give you another simpler question thereafter, but nevertheless, you can try this question. I think it will illustrate the point I was trying to make. In fact, let me give you options as well for this question. I've given you 4 options for question number 1. Why don't you try this? Any answers to question 1, guys? Any answers to question 1? Okay. 11:30 is not the right answer, Krishna, I'm afraid. 11:06 may be the right answer, Lakshay. Let's see if others agree. 11.6 is the right answer. I don't know if others have not solved or uh, how. Now, the only thing I want to repeat, as I said, when I was talking about relative speed, the only thing I want to say here is so there are 2 points, Delhi and Agra. The train from Delhi leaves at 8 a.m. to reach Agra at 12 p.m. Takes 4 hours. Yeah. The train from Agra leaves at 10 a.m. to reach Delhi at 3 p.m. It takes 5 hours. This train is taking 5 hours. This is taking 4 hours. Now, since they're starting at different times, it makes sense to bridge this first. Yeah. And you could have assumed here again, you could have assumed some distance. Since this question doesn't talk about distance at all, you could have assumed distance to be the LCM of 4 hours and 5 hours. You could have assumed distance to be 200 kilometers. It would not have changed the answer. Let me just assume it to be D. Let's just take this distance to be D for the time being. 200 kilometers would have worked as well. Now, what do I know about the train from Delhi to Agra? Let me call this train 1 and let me call this train 2. I know about train 1. I know that the speed of train 1 must be covering, since it covered distance D in 4 hours, it must be D by 4. I know that the speed of train 2 must be, since it's covering D in 5 hours, speed must be D by 5. To use the concept of relative speed, it makes sense to first let the first train 1, run till 10 a.m., which essentially means letting it run for 2 hours out of 4 hours. Letting it run for half the time, which obviously means that if it's running for half the time of the total, it would have already covered half the distance. And at 10 a.m., it would have been at the half point, the midpoints on the train 1, moving towards Agra. And at 10 a.m., the other train would have started moving towards Delhi with the relative distance between the two equal to D by 2. And the formula, of course, says relative distance is the relative speed into time after 10 a.m., after both have started moving. Relative distance they'll cover must be D by 2, to meet each other. Relative speed, since they're both moving in opposite directions, relative speed will be addition of these speeds we have calculated. So relative speed will be D by 4 plus D by 5. And thus time you can immediately calculate. This is D by 2, D by 4 plus D by 5, simplify, get a 20, take the LCM and solve it. This becomes 5D plus 4D by 20 into T. D is obviously going to cancel. We've discussed that before. And if you solve this, you will get your answer as 20 by 18, which is obviously also 10 by 9 hours. The common time, T is the common time for which both trains are running and moving towards each other, is 10 by 9. It's more than 1 hour after 10 a.m. So they will meet at, the time they'll meet will be 10 a.m. plus 10 by 9 hours, which will be approximately 11:06 a.m. In fact, if you were to have a look at the options, you wouldn't really need to calculate. You would understand it's more than 11, but can't be 11:30. So the right answer has to be 11:06. Is this clear, guys? Is the concept of relative speed clear? Okay, excellent. Now, I'd given you a sheet. I'd sent you a sheet